Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics Chapter 2 Differentiation Long Question Example 8. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. The diagram shows a metal sphere suspended from a piece of string L meter in length, oscillating about O with a period of t second. Okay, so this is the string which is oscillating with a length of L meter. So continue to read the question. It is given that t is equals to k square root L, where k is a constant. So continue to read the question part A. Express L in terms of k and t, and hence find dl over dt in terms of k and t. Continue to read the question part B. Show that the approximate increase in the period of the oscillation when the length of the string is increased from 0.81 meter to 0.83 meter is k over 90 seconds. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Let us begin our discussion for the question part A, where we need to express L in terms of k and t, and then we need to find dl over dt in terms of k and t. Okay, so the first step what we need to do is we need to write down the equation of t is equals to k square root L. So t is equals to k square root L. So using the algebra formula, we need to express L in terms of k and t. So from this equation, we need to form square root L in terms of k and t. So for that, what we need to do, square root L will be equals to t, you divide with k. So for the next step, what we need to do is we need to square both sides. So why we need to square both sides? In order to eliminate the square root of the L. Okay, so from here you get your L is equals to t over k square, and then you should get your L is equals to t square over k square. Okay, so this is your first part. So let me underline this. So once we get this, we can proceed to do the differentiation. Okay, for the differentiation, we're going to alter this equation a bit. So what we're going to do is we're going to factor out the constant. So from here, L will be equals to 1 over k square, and then in a bracket t square. Okay, since 1 over k square is a constant, so why I'm doing this, so that it will be easier for us to differentiate L with respect to t. Okay, so from here, let us perform the differentiation. So from here, dl over dt will be equals to 2 over k square, and then it will become t over here. So that means the 2 you times it 1 over k square, and then the 2 it will reduce to 1. So that's how you get 2 over k square times with t. Okay, so this is your answer for the question part A. Okay, let me underline the solution. Okay, so I hope you understand the full working that I've shown to you for the question part A. Let us proceed our discussion for the question part B, where we need to show that the approximate increase in the period of the oscillation when the length of the string is increased from 0.81 meter to 0.83 meter is k over 90 seconds. Okay, so part B question is involving the approximation concept. So we can start to obtain the information from here itself. So from here, it mentioned that the original length is equals to 0.81 meter, and the new length of string is increased to 0.83 meter. Okay, so from here, to find the change in length, so from here to write the change in length, it will be delta L. So your delta L will be equals to new length you minus with the original length. So the new length you minus with original length. So from here it will be delta L is equals to 0.83 minus with 0.81. So from here you should get your delta L is equals to 0.02. Okay, we have already obtained through this. Okay, let me underline this information. Okay, the question requires us to find the delta t. Okay, in this case we need to prove that delta t is equals to k over 90 seconds, but we don't know how to do that. So from here delta t, so we just left it as question mark first. Okay, so for now let us continue for the next step. Then you can wonder why I write here the question mark. So don't worry guys, I will get back soon. So from here what we're going to do is we're going to write the original equation given by the question, where t is equals to k square root L. Okay, in this case the t stands for the period, k is the constant, and L, I mean square root L, is the length of the string. So this is the pendulum equation guys. Okay, from here let us perform the differentiation. So we're going to differentiate t with respect to L guys for this question, for the question part B. Okay, so from here t will be equals to k L to the power of 1 over 2. At least it will be easier for you to perform the differentiation. Okay, now you can perform the differentiation. So from here dt over dl will be equals to 1 over 2k. Okay, you can wish to write 1 over 2k, or if you want to write k over 2 also can, but I wish to write k over 2, at least it will be easier for us. So from here half times with k, so you get k over 2 L, and then half you minus with 1, so from here you get L to the power of negative 1 over 2. Okay, so I hope you understand guys. Okay, so from here this index we're going to bring it down to the denominator. So from here dt over dl will be equals to k over 2 square root L. Okay, let me underline the fraction. Okay, so to find the delta t we're going to use the approximation concept guys. Okay, so how to use the approximation concept? Okay, let me write down the formula here. So it is given that delta t over delta L should be approximately same as dt over dl. Okay, so this is the formula guys that we're going to use to solve for this question. Okay, let me box this. Okay, so delta L we know, dt over dl we also know. The only thing we need to find is the delta t. Okay, so from here let us continue. So from here delta t is approximately same with dt over dl. Okay, you times with delta L. Okay, so from here you find the dt, I mean delta t. Okay, approximately same. So from here k over 2 square root 0.81. Okay, and then you times with delta L. Okay, in this case the delta L is 0.02, the one we have find earlier guys, the delta L, through L new minus L original. Okay, I hope you understand. So let us continue. So square root 0.81, so you calculate this, you should get 0.9. So 0.9 times with 2, so from here you get your denominator is 1.8. So from here delta t is approximately same k over 1.8, and then you times with 0.02. Okay, so from here you simplify this. you get 1, and then you simplify this, you get 90. So from here you should get your delta t is approximately same k over 90 seconds. Okay, we have successfully proved that our change of period is approximately k over 90 seconds, just like the question mentioned over here. Okay, it means that our answer is correct, guys. So let me underline the solution. Alright, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. And not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.